And welcome to my presentation. And the presentation will be about the degradation of selected fibers as a function of maintenance cycles. And my name is Magdalena Młynarczyk, and I'm from Central Institute for Labor Protection, National Research Institute in Poland. Sustainability in the text industry is becoming an increasingly important issue, especially in the protective clothing sector of workers. So the selection of materials directly impact the environment, and responsible production and recycling can significantly reduce negative ecological effect. When we use for the production of protective clothing, the synthetic materials such as polyester, polyamide, or aramides, we also, due to their durability, resistance to mechanical damage, and properties. However, these materials have a large carbon footprint and a long time to decompose in the environment, and their production process requires large amount of energy, water, and generates harmful chemical emission. Among the main ecological challenges now related to protective clothing, the problem of microplastic relates during washing. The synthetic clothing can be distinguished, and therefore natural organic fibers such as cotton or man-made cellulosic fiber as viscose are recently used in the production of protective clothing, which often an alternative to synthetic. The organic cotton is biodegradable, skin-friendly, and breathable also, and ensures greater comfort of use. Viscose produced from wood cellulose and combines the advantages of natural fibers, which has moisture absorption and good breathability. In our study, 4 textile materials used in protective clothing. The clothing was protection against heat. And we use the fibers which consist viscose, cotton, and synthetic fibers. All materials, indeed, the protective clothing against heat and completed with the standard which you see in the slide. The scanning electron microscopy was used to examine the impact of maintenance cycles on fiber morphology. So the research aims to optimize fabric production process using cellulosic fibers, and this study examines the impact of maintenance cycles on the morphology of natural and artificial fibers compared to synthetic fibers, as well as their condited usability while maintaining appropriate thermal properties. So we have here 4 different materials, and we tested in the unwashing state, so the new one, and after 5 cycles, after 20 cycles, so together after 25 cycles, and after 50 cycles. And we have the 4 samples with 0% of cellulosic fibers, 35% of cellulosic fibers, and also 75% and 100%. We washed the samples according to 6030 standard, and a scanning electron microscopy was also used to see the impact of maintenance cycle on fiber morphology. And the thermal parameters were tested by the hot plate or skin model. And as you can see in the first row, we see the new state, the unwashed state, and the row below is the same images after 50 cycles. And what is the results about cellulosic fibers? We observed the degradation of cellulosic fibers after only 5 maintenance cycles, the cellulosic fibers degrade through delamination, and we also observe the same as literature said, that it is the way of degradation of cotton fibers. What about synthetic fibers? Here also notice some defect, but the gradation of synthetic fibers was not as noticeable as cellulosic fibers. And we also used preservation had minimal effect on the morphology of synthetic fibers. And here the surface degradation through delamination and deformation of voids and pores was not noticeable also. So as a result, microscopic analysis showed us that all fabric fluffy up under the influence of preservation. The increase in the number of those threads and changes in the dimension of the wheels and were observed. The greatest shrink and loosening of the yarn structure after 50 washing cycles was observed in case of fabric 0, where the only synthetic fibers were. And what about thermal parameters? So here you can see the results from skin model, and here all fabric observed that the greatest increase in the thermal resistance occurs after 5 washes. And when we tested the fabric with 100 cellulosic fibers, the smallest changes in thermal resistance of washing here, and the decrease in thermal resistance after 25 washes with a parallel increase in the thickness indicate a losing of the yarn structure and a loss of or degradation of fibers. Here also show the percent difference between these thermal parameters. So for the materials 0% cellulosic fibers, we show the significant increase in thickness even after 25 wash cycles. And we also indicate that high tendency of shrink that, and at the same time an increase the thermal resistance. The drastic decrease in the thermal resistance of the 0% of cellulosic fibers after 25 and 50 wash cycles indicates intensive degradation of the yarn structure in the fabric and lost the fibers, which is confirmed by seam images. To conclude, the characteristic phenomenon after the 5 first washes is a significant increase in the thickness of the fabric, regardless of the type of fibers used, which similarly results in the decrease in the thermal resistance. All fibers show a significant decrease in the thermal resistance after 50 washing cycles. Degradation of fabric under the influence of maintenance occurs in both natural and synthetic fibers, and the rate of degradation depends on the type of fibers. Cellulosal fibers degrade faster. On the other hand, degradation of synthetic fibers causes the emission of nanoplastic into the environment. Analysis of our results showed that adding 35% of cellulosic fibers to fabric reduced the composition of synthetic material in production without significantly changing in the essential parameter of protective clothing. So partial replacement of synthetic fibers allowed for the reduction of the use of petrochemical raw materials, reducing in the impact of production on the natural environment. So this is the new one for us, the process to optimization of the new fabric to reduce negative impact on environment. So thank you for your attention.